All right, so here we have an object that's slowing down while moving in the negative direction. You can see that because our position time graph slopes get less steep, and these slopes are all negative. So that means you're slowing down in the negative direction till about here, at which point the object changes direction and then speeds up while moving in the positive direction. Okay, and these slopes on this side get steeper and they're all positive, meaning the object's going faster in the positive direction. This is a position time graph. So these slopes are our velocities. And these velocities are negative until here, at which point the car stops and then moves in the positive direction because these velocities are all positive. And we can take the slope of our velocity graph. That will give us an equation representing the velocity of the car at different moments in time. Okay, and looks like I got a acceleration of 0.076 meters per second per 1 second, meaning every second this fan cart changes its velocity by 0.076 meters per second. And the initial velocity at 0 seconds looks like it's about negative 0.4 meters per second. Okay, so now I can use that information to model the position time curve. I'll go analyze model. And for my B value, I'm going to make it negative 0.4046. I can take half of my acceleration. Use a calculator for that. 0.07634 divided by 2, and I get 0.03817. Okay, so I'll put that there. 0.03817. And you can see this curve is very close to our data. Now I'll make this interval really small, 0.01, and I'll gradually change my initial position till my curve comes close to our data. Pretty good, looking good. Maybe I'll make this interval smaller, 0.001. But that looks pretty nice. I can live with that. I'll hit OK. So now we have a position time graph and velocity time graph for our car. Let me show you these equations real quick. All right, so I want to write an equation for the position of our car. It'll be position equals, take this number, 0.04, and then this number will have units times t squared, plus negative 0.4, and that number is going to have units times t, plus 0.3, and that number is going to have units. Well, the easiest way to figure out the units is to look at the equation itself. Position has to be in meters, therefore this number has to be in meters for the equation to be correct. If you look at this term, you have a number times t, and the units have to work out to be meters. So the only units that would work there if this whole thing, this whole term is going to be in meters, you need meters per second here. And it turns out that term is going to be our initial velocity. And this term also has to be meters, because you have to have meters plus meters plus meters to give you meters. So 0.04, the only way for the 0.04 times t squared to give you meters is if the units are meters per second per second. So that makes that whole term measured in meters. Okay? So the general equation, therefore, has to be position equals this term here should be about half of this term here, because the equation for velocity is v equals 0.076 meters per second times time minus 0.4 meters per second. Well, this number was our velocity at 0 seconds. Given the symbol v with a small 0. And then this number here is, it means every second the velocity changes by about 0.08 meters per second. This is our acceleration. So the general equation becomes velocity equals acceleration times time plus initial velocity. And this is a vector equation, meaning that all of our terms except for time have information about direction. And then above, I'll write a general equation for position. Position is going to equal, now, you'll notice our A term here turned out to be 1/2 our acceleration. So position is going to be 1/2 times acceleration times time squared. A little hard to see that. I'm going to write it down here. Okay? So again, our general equation is going to be about up here. Position equals 1/2 our acceleration times time squared. That takes care of this term. Plus, and from down here, you see that the 0.4 meters per second is our initial velocity. That's got to be multiplied times time. Plus, the 0.3 meters has to be, this is measured in meters, it's our initial position. So it's our position at 0 seconds. All of these terms have information about direction. We have position, acceleration, initial velocity, initial position. So they're vector terms, and this is a vector equation. Okay? These are our two fundamental equations that we use when dealing with an object that moves with constant acceleration. Anyway, hope you enjoyed the screencast. Hope it helps you understand. Have a good day.